Welcome to the Rich Report, a podcast with news and information on high performance computing. Today, my guest is Rob Farber. He is an author and analyst, and especially in the space of GPU computing and high performance computing. How you doing today, Rob?
I'm doing really well, Rich, and thank you for having me online with you today.
Well, thanks for coming on, Rob. We did this kind of a review last year at the GTC conference, and I thought this might be a great time to revisit that in light of what's going on with mobile computing and Nvidia and GPUs.
Oh, yeah, there's some very exciting things happening, of course, with the CES announcements. And at stake is a billion plus one processor per customer mobile market play, plus the HPC play. There's a lot of things happening in the industry right now.
Okay, yeah. So we used to kind of ignore that mobile market at Inside HPC, but as you just mentioned, there's some overlap and more coming soon. Let's take a look at what Nvidia announced this week because I think it's going to lead into some of the topics you wanted to cover. They rolled out something called the K1 processor. Two versions, a 32-bit and a 64-bit, which is the first peak we get at Project Denver.
Oh, yeah.
Did you get to see that announcement?
Yes, I did, and I think it's a very shrewd play. I like it quite a bit, as you can tell. The 32-bit goes to that billion processor mobile cell phone market space, and then the 64-bit goes to the power efficiency in the enterprise space. So, and of course, with the tail wagging the dog, of course, that moves into the HPC space as well. So, I'm seeing some extraordinary increases in performance per watt coming down the road. And I'm very excited by both of these announcements, both the 32 and the 64-bit.
So let's get into some of the specifics then. So what we saw with what we thought was going to be the Tegra 5, just another, turned out to be something a little bit different. It's the K1. This is the first appearance of the Kepler architecture for mobile devices. And Rob, what does that bring to the table then? Is this bringing CUDA to mobile?
Oh yeah, it's bringing CUDA to mobile. It's bringing the Kepler architecture with the high speed rendering, the tessellations, the big gaming, all in a power factor that that is really efficient, about 250 times more efficient. If you've seen the demo that NVIDIA gave with the completely artificial machine generated photorealistic face. Boy, there's a group of buzzwords for
Yeah.
you. But they're doing this completely in real time on the K1. And the previous instantiation of that, they're doing it in 1 watt. Meanwhile, the Titan GPU took 250 watts to do that same kind of thing. So we're going to see the movement of the Kepler power performance efficiency moving into mobile at some serious battery lifetime extensions and gameplay and wonderful things happening for the mobile market space with all that performance and power, assuming NVIDIA can meet the software needs for the platform.
Sure, sure. And along those lines, Rob, now what does the fact that this is Kepler, is this code compatible with the GPUs we've come to know in big machines like Titan?
Oh yeah, yeah.
Yeah.
In fact, I'm looking to write some introductory CUDA articles using the K1 as the introductory platform, so that you can start programming your mobile phone in CUDA. And of course, that opens up the world to OpenACC as well, which means pragma-based programming.
Okay, I guess you had some predictions coming up here. I don't want to preview those too much, but what does that mean? I mean, if OpenACC suddenly has a window into that mobile market, what does that mean in terms of adoption?
Well, that's a really good question, Rich, and I'm not quite sure. Uh,
Yeah.
my what I'm seeing is that basically NVIDIA is showing how scrappy they are because they're going against Qualcomm in the hardware space with these 32-bit offerings. Qualcomm currently owns 53% of the market share.
Yeah.
Nvidia owns about 7%. So I
Mm.
love verifiable or at least checkable predictions. So my guess is that because of the high resolution displays, essentially the 4K displays uh, that are now in all the mobile devices and TV is going to 4K, is that Nvidia's 7% market share is going to jump significantly. So then directly answering your question, Nvidia is also showing that they're being very scrappy in addressing the needs of the parallel programmers that have been dominated by Intel and OpenMP with OpenACC, the OpenACC specification that allows programming of discrete accelerators and coprocessors. So the prediction is that if the K1 actually gets adopted, then OpenACC can be considered as a programming platform from mobile, the programming language platform, possibly of choice, from the mobile market through the enterprise to the HPC market space. So it's basically one programming language to rule them all through the underlying CUDA platform. It's quite quite an aggressive strategy, and it's going to make for a very interesting 2014 and possibly 2015 as well.
Okay, so with that inclusiveness, Rob, what about couldn't you use OpenACC to program, say, Xeon Phi cores as well?
Uh, Absolutely. In fact, I've actually seen PGI and CAPS demonstrating that.
Yeah,
So
yeah.
basically, one source code running on AMD GPUs, Intel Xeon Phi GPUs, ARM, NVIDIA GPUs, multi-core. So basically, you write one source code, and then you essentially use the compiler to generate the executable for whatever your target platform is. It's very exciting.
Yeah, yeah. And then, so looking at your number two item here, battery power, power efficiency is everything in mobile devices. If you don't have that, you don't really have a play. 4K sounds to me like you're going to have to move a lot of information around, and how can you possibly do that with a low power device?
Well, thanks, Rich. That item two, by the way, that's from my latest scientific computing article, kind of summarizing the bullet points,
Yeah.
which is mobile tech between a rock and a hard place, because the rock is, of course, the high resolution displays where you've got to move that huge amount of data, and the hard place is battery life. So that's where the NVIDIA demonstration is so interesting, that they've gotten a 250 times uh, reduction, essentially to do an augmented reality type of application running on a mobile processor. Very exciting.
We saw an excellent demo of this. They were basically looking around a living room with a hardwood floor and with some tremendous, light refractions, light coming from everywhere, multiple shadow, uh, very photorealistic. And it was hard for me to believe that this wasn't some very high-end workstation producing this image. It was like it was a mobile device. So,
So imagine your effectively 4K television cell phone
hmm
rendering that in real time using only 1 watt of power, so that you actually have decent battery life. You can be on the airplane flying around. You could be playing a game while you're waiting for your kid to finish work at school. Your kids can be playing on the phone so that you have a little bit of free time. So that's the the output portion of the mobile market, where you want to view not just eye candy, but you actually want to view much more exuberant apps. And the reason why I say exuberant is the industry has gotten to this point right now by essentially making traditional GPU architectures more power efficient. So these are non-NVIDIA GPUs and early NVIDIA GPU type of architectures and gaming engines, rendering strategies as well. And what that means is that you've got essentially fixed function, not general programmability like the Tegra K1, but just fixed function that can be accelerated. And that's really worked well. It's worked well for Apple because they have their locked-in ecosystem. It's worked well for Android because Android can go to the lowest common denominator to get very fast 2D acceleration. We're now moving into the world where we want customers want more exuberant apps, more eye candy, attention grabbing apps, and more informative apps where you need to program in real time in 3D. And that's where the animated face demo that you're going to be putting up on this podcast really shows the potential for augmented. So my guess is also there's going to be in 2015 a gold rush of augmented reality types of gaming apps where people are going to be starting to use their cell phones and the gaming consoles, running around and playing tag and treasure hunts and all sorts of wonderful things because of the general purpose programmability. In other words, we've broken the straitjackets of fixed functionality but gone to more general programmability. Again, that's going to be a very lucrative and very interesting market space because people are moving beyond fast scrolling and that. So very cool.
Okay, so you've kind of cracked two nuts here. You've got a highly parallel device, 192 cores, I
Hmm.
believe, right? So that's not easy to program, but what you've just described is a way to get it done, and a way to get it in the hands of not just supercomputer scientists, but everyone who might be using a mobile device.
Well, in fact, I would use the counter argument that with OpenACC and with CUDA, in fact, go through my tutorials. It should be relatively straightforward to program. I won't say easy because high performance programming is never really truly easy, but it should be fairly straightforward to make use of all those cores. A better way of putting that in perspective, though, is the Tegra K1 is rated at 360 gigaflops per second. That's more than 6 times faster than the fastest supercomputer I could get access to as a staff scientist at Los Alamos National Laboratory in 1993. And that's consuming 1 watt
1 watt.
power when it's running full out, if you can believe the Nvidia benchmarks for the augmented reality face.
Yeah, yeah. So in terms of the market, Rob, we've got Nvidia's kind of the underdog here. As you said, Qualcomm has over half the market. Um, but it takes more than technology to win in this market. If you were a betting man, do you think they're going to get some traction here?
Well, as a betting man, I usually only bet when it's a sure thing. So, because I like to win. Hey, who,
Yeah,
who
yeah.
wants to lose money? I want to make money. So, what I'm seeing is that NVIDIA is doing the right things. I mean, they are carrying on a multi-front hardware-software war, but, or maybe not war is not the right phrase, but they are making incursions into the market space of some big players, namely Qualcomm and Intel. And software has been traditionally the weak point for NVIDIA. They've got great hardware, and that's a very surprising thing to say for a company that developed and got CUDA out and has taken the HPC world by storm,
Yeah.
which is quite good. However, the problem in the mobile market is getting the different game engines to run so that you can be running those traditional high performance games on your cell phones.
Hmm.
And NVIDIA has put out in their press release that pretty much all of the major game engines are now running, and it's pretty much they just now run the new high resolution games or on the K1. So it's not even a porting project. It's just basically getting it to run. So with that in mind, I think anybody who's interested in gaming will definitely be moving to NVIDIA. So my bet is that NVIDIA is going to definitely take a considerable amount of market share because of that. People also, because of the high resolution displays, tend to move to NVIDIA because they have the hardware chops to handle those displays interactively. So that also is a good sign that a bet on the NVIDIA K1 technology is going to be a safe bet. More than that is that even though the software vendors, Android, Apple, all the other different companies have to program to the lowest common denominator, there is serious consumer demand to bring in more flexible, more interesting applications. And furthermore, we haven't even talked about the input part, which is the camera. And not only is the NVIDIA hardware good for video decode, but it's also good for video encode. In other words, you could use it as a high resolution camera and as a high resolution video recorder as well, with some very good camera hardware. So with all those things, I'm seeing that the K1 really addresses a multiple set of pain points in the mobile marketplace, and it leverages NVIDIA's investment in the HPC space. So I'm very bullish on the NVIDIA um, play with the K1. I think it's very exciting. I think Qualcomm is doing some very nice things, but they're taking a more conservative approach, which is consistent with that of a market leader with 53% market share. They don't want to mess anything up. And because of that, NVIDIA has an open road to run to try to make, as they say, hay while the sun shines. In other words, exploit this market opportunity.
Okay, Rob. So looking forward, what do we expect, to come out of this with Denver and these kinds of devices for exascale computing?
Well, I think that we have
Hmm.
some very good ramifications from the Project Denver,
Hmm.
because
Hmm.
in this case, the billion plus cell phone market is exactly aligned with the exascale compute capability supercomputers that we all want to build and model our own big simulations to understand the world. And that is because of the flops per watt.
Yeah.
So just as Project Denver gives us a very high flop rate for a very low amount of power consumption, which you need for long battery life, so does it also give us very high flops for low power consumption, so that even governments who want to combine so many of these together to give the exascale type of computational flop rates, uh, they can't afford to pay for a large amount of power unless the devices are very power efficient. So in this case, the Kepler ARM combination with Project Denver gives us some real great hope for some very power efficient exascale or towards the exascale supercomputers coming down the road, probably to be bid in the 2015, 2016 timeframe. The Barcelona supercomputer project has already shown that you can build an ARM-based supercomputer out of NVIDIA chips. But with the advent of the Kepler programmability and system on a chip, that makes it just that much more powerful and that much more cost efficient from a procurement and from an operating standpoint. So I'm very, very excited about the potential for some really wonderful exascale type hardware to be announced and coming down the road in the next few years. It does take a little bit of time to get this integrated. And with the 64-bit, it's a no-brainer that they're going to be bid. Whether they win the bids is an open question, of course.
Right. Well, Rob Farber, I want to thank you once again for coming on the show today.
Hey, always a pleasure, Rich. You've got a great audience. I love the rapport that we have and chatting with you. And my wish is that may your audience grow ever larger in 2014.
Well, with your help, we'll see what we can do there. All right, Rob. Well, hey, folks, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.